Hello student, welcome to my channel. Last day we come to know about the topics metallurgy. Today we are going to discuss about the topics electricity and chemical reactions. So at the beginning of electricity and chemical reaction, we discuss about electrolytes, non-electrolytes, strong or weak electrolytes, etc. So let's start. First, electrolytes. Substance or substances which conduct electricity in molten state or in solution and undergo chemical transformation during the passage of electricity are called electrolytes. There are various examples of electrolytes, as for example acids, hydrochloric acid, sulfuric acid, nitric acid. Alkalis, sodium hydroxide, potassium hydroxide, calcium hydroxide, etc. And salt, sodium chloride, calcium chloride, copper sulfate, etc. Now, non-electrolytes, substances which do not ionize and do not conduct current even in the molten state or in aqueous solution are called non-electrolytes. Now, the classification of these electrolytes. First, strong and weak electrolytes. What is strong electrolytes? An electrolyte which is completely ionized in aqueous solution is called strong electrolytes. As for example, see the above examples, that is acids, alkalis, salts, those examples are fit for these strong electrolytes. And an electrolyte which is not completely ionized in aqueous solution is called weak electrolytes. As for example, acetic acid, CH3COOH, and ammonium hydroxide, NH4OH, etc. Now, what is the difference between strong and weak electrolytes? There are so many differences between strong electrolytes and weak electrolytes. First, strong electrolytes are good conductor of electricity, whereas conductance is relatively low as compared to strong electrolytes. Strong electrolytes are dissociate almost completely in solution and produce large number of ions, whereas in case of weak electrolytes, partially dissociates and hence produce less ions in solution. Number 3, strong electrolytes are generally ionic compounds. Number 3, weak electrolytes are generally covalent compounds. And number 4, the solution of strong electrolyte contains ions, whereas the solution of weak electrolytes contains ions as well as undissociated molecules. Now, what is metallic conductors? These are a metallic substance which allow the passage of electricity through it without undergoing any chemical changes. The examples of metallic conductors are aluminum, copper, iron, etc. Now, the difference between metallic conductor and electrolytic conductor. What is the difference between these two types of conductor? Number 1, metallic conductor. Conduction through metals is carried by movement of electrons, whereas conduction through electrolytes is carried by movement of ions. Number 2, no change is observed in the chemical properties of the conductors. It involves chemical changes resulting in the decomposition of electrolytes. In case of metallic conduction, it does not involve any transfer of matter, whereas in electrolytic conductor, it involves the transfer of matter as ions. In case of metallic conductor, it shows increase in resistance with the increase in temperature, whereas in case of electrolytic conduction, it shows decrease in resistance with the increase in temperature. Number 5, the conductivity of metals is generally high, whereas the conductivity of electrolytic solution is generally low. And the last point is metallic conductors conduct electricity both in solid or liquid state, as for example mercury, whereas the electrolytes conduct electricity only in molten state or in solution. Now we discuss about the properties of electrolytes. The first properties is electrolytes are dissociate completely or partially in solution or in molten state to positively charged ion and negatively charged ion. Number two, positively charged ions are called cations and negatively charged ions are called anions. Sometimes the number of cation and anion are not equal in solution, but the total positive charge of cation is always equal to the total negative charge of anion, and therefore the solution is neutral as a whole. Next point is, if potential difference is applied by means of definite electrodes, the cations are moved towards cathode and anions are moved towards anode. In this way, that means cation and anion, transport electricity. Point number 5, the conductivity of electrolytic solution depends upon the nature of electrolytes, concentration of solutions, and temperature of the solutions. Now there is a question arises. Sodium chloride conduct electricity only in solution or in molten state but not in solid state. Why? The answer is sodium chloride is generally crystalline solid at normal condition. In crystalline state, the cations and anions are strongly held together by electrostatic force of attraction. As the ions cannot move in solid state, NaCl cannot conduct electricity. In solution, the ions are separated and the force of attraction becomes weak. Hence, the mobility of the ions increases. As a result, the solution conducts electricity. Now, what do you mean by electrolysis? Electrolysis is a process of decomposition of a chemical compound due to passage of electricity through its aqueous solution or through its molten state producing new substance. There are some important things related to electrolysis. Number one is voltmeter. It is a device used to convert electrical energy into chemical energy through electrolysis. Electrodes. Electrodes are metallic or non-metallic plate or rod by which electric current or energy passes into the electrolytic solution in the time of electrolysis. Now these electrodes are classified into two classes. Number one is anode and number two is cathode. What is anode? The electrodes which connect with the positive pole or end of a cell, that is battery, is called anode. And what is cathode? The electrode which connect with the negative pole or end of the cell, that is battery, is called cathode. In anode, oxidation takes place, and in cathode, reduction takes place. Now we discuss about ions. That is, what is ions? The charged atoms or group of atoms are called ions. Ions are two types. The positively charged ion is called cation and the negatively charged ion is called anion. Now we discuss about the application of electrolysis. There are so many applications of electrolysis. We particularly discuss about 4 points. Number one is electrolysis is used to extraction of highly reactive metals, as for example sodium, potassium, calcium, aluminum, etc. Number two, electrolysis is used to electrolytic refining of metals, as for example copper, silver, aluminum are refined by the process of electrolysis. Number three, electrolysis is used to manufacture of some chemicals in large scale, that is industrially, as for example oxygen, chlorine, sodium hydroxide, etc. And the last point is electroplating on metal surface. Now we discuss about the electrolysis of acidified water by using platinum electrodes. At first, what is used as cathode and anode? Here, platinum electrodes or foils are used, cathode and anode in both cases. And what is the electrolytes? Here, the electrolyte is acidified H2O. Actually, H2O is not a good conductor of electricity, so we just mix up some acids to make water as a good conductor. Now, what is the dissociation of acidified water? H2O liquid, it dissociates into H positive ion and H negative ion, and here we use the acid is sulfuric acid, and sulfuric acid dissociate into 2H positive plus SO4 double negative. Now, a reaction at the cathode, here H positive, that is hydrogen ion, take one electron to make hydrogen atom. 4 hydrogen atom converted to 2 hydrogen molecule. Now, a reaction at the anode, here H negative ion, from H negative ion one electron is removed and it become OH radical. 4 OH radical become 2H2O plus O2. So at cathode hydrogen is produced and at anode oxygen is produced. The ratio of the volume of hydrogen and oxygen at cathode and anode 2:1. This is the main points of the electrolysis of acidified water. Now we discuss about the electrolysis of copper sulfate mixed with dilute sulfuric acid using active copper electrodes. Here we used copper electrode as cathode and anode. That is, in both cases, cathode and anode, we used copper electrodes. Now, what is the electrolytes? Acidified, that is, acid is H2SO4, acidified copper sulfate solution, and the dissociation are as follows. Copper sulfate in liquid state, it dissociates into copper double positive ion and sulfate double negative ion. Sulfuric acid in liquid state dissociates into 2H positive ion and SO4 double negative ion. And H2O in liquid state dissociates into H positive ion and H negative ion. Both copper and hydrogen ions will move towards cathode, where copper double positive ions are discharged in preference to H positive ion. As a result, metallic copper deposit on the cathode, whereby the weight of copper cathode increases. On the other hand, both OH negative ion and SO4 double negative ions move towards copper anode, but none of them is discharged there. Electrons are more easily removed from copper anode since ionization potential of copper is less than the discharge potential of SO4 double negative ion and OH negative ion. Thus, copper anode itself ionizes. As a result, copper atoms from anode gradually pass into the solution as Cu double positive ions. Hence, the weight of copper anode decreases gradually. The reaction at cathode is Cu double positive ion plus 2E, that is copper, and the reaction at anode is Cu minus 2IC, Cu double positive ion. Now, what is electroplating? The electrolytic process of giving a coating of thin film of one metal over another is called electroplating. What is the purpose of electroplating? Number one, a reactive metal or its alloy are easily attracted by atmospheric oxygen, water vapor, carbon dioxide, and undergo corrosion. To prevent corrosion, the article is electroplated by a less reactive metal. And number 2 point, the second point is to increase the physical appearance more attractive. As for example, when silver jewelry are electroplated with gold, they become more attractive. And the last one is to increase their commercial values. Now, what is anode mud? During electrorefining of copper, the more electropositive metals, as for example iron, nickel, zinc, etc., present as impurities in impure copper anode move into the solution, and the less electropositive metals, as for example gold, silver, platinum, etc., deposit with other impurities below the anode as mud. This is known as anode mud. Now there are some points to remember relating electroplating. We discuss about 3 points. The first point is the substance which is to be electroplated is used as cathode. The metal which is coated over the substance is used as anode. And number 3, electrolyte is always water soluble salt of metal by which electroplating is done over the substance. Now we discuss about the name of electrodes and electrolytic solution used in electroplating an article with the following metals. Number 1 copper, number 2 silver, number 3 nickel, number 4 chromium, number 5 gold, and number 6 tin. The metal used for electroplating is copper. We can use cathode. The article which is to be electroplated, pure copper is used as anode, and electrolytic solution is copper sulfate solution, CuSO4. When we used silver metal for electroplating, always the article which is to be electroplated used as cathode, pure silver is used as anode, and potassium argentocyanide solution is used as electrolytic solution, and the formula is KAgCl2. Tin, when you use tin for electroplating, the article which is to be electroplated is always used as cathode, pure tin used as anode, and stannous chloride solution SnCl2 is used as electrolytic solution. When you use nickel for electroplating, the article which is to be electroplated is used as cathode, pure nickel is used as anode, and nickel sulfate solution is used as electrolytic solution, NiSO4. When you used chromium for electroplating, the article always used which is to be electroplated as cathode, and pure chromium is used as anode, and chromic sulfate Cr2SO4 whole 3 or chromic acid H2CrO4 is always used as electrolytic solution. And the last one is gold. When we used gold for electroplating, the substance or article which is to be electroplated is used as cathode, pure gold is used as anode, and potassium orocyanate solution KaUCN2 is used as electrolytic solution. So we have finished our chapter. If you have any doubt or you face my problem while going through my video, then please let me know or write in the comment box. Hope you like it. Thank you.